Welcome to the wonderful world of programming using C and C++. This presentation introduces your first programming project in the class, the Paycheck program. Watch this video carefully. It not only covers the first project, but many of the small details in the C and C++ programming languages. You may want to watch this video more than one time, especially if this is your first class in programming. You not only need to complete the project, but you also need to understand the information presented because it forms the basis for all of the rest of the class. As the course progresses, you will be required to start a project from scratch and create the entire project yourself. I will cover the Paycheck lab assignment by discussing the project definition and how to develop an algorithm. I am sort of ambidextrous. I can use a Mac and I can use a PC. I will start with the project definition and then show you how to create a C or C++ program on either of these platforms. I will be using Visual Studio to create the project in Windows, and I will be using Xcode to create the project on a Mac. You can use either of these computers or even Linux. However, the only ones I'm covering are Visual Studio and Xcode. After you have created the program, you need to make it work. Test it by using several different values, then complete and submit the lab report. Before you even start, I suggest that you create several folders on your computer or storage device. The main folder for the CIS54 C programming class, one subfolder to keep copies of all your lab reports, a separate subfolder for each lab project. You may want another folder to keep copies of class presentations. The college removes the Canvas web page about a month after the end of the class. Here's the project definition. Create a program using C or C++ that does the following. Read the number of hours worked and pay rate. Compute the pay, including overtime at time and a half. Change the withholding tax from 17% to a new value between 5% and 25%. Compute the taxes, display gross pay, taxes, and net pay. When you create the program, use a different value for the tax rate as long as it's between 5% and 25%. Even if you are really smart and know how to pay no income tax, the tax withheld for this project must be between 5% and 25%. The first thing you should do when you are given a programming task is to figure out what the output should look like. Draw it out on paper. As the project progresses, don't worry if the actual program output does not look exactly like your original plan. Plans can change. Pseudocode is fake code. It's code that it's not really in any language. It's more in English. A lot of times pseudocode is given to the programmer to say, here's how I want the program to work, and it's up to the programmer to write the code in C, C++, Java, or whatever language is being used. In this hierarchy, input, process, output chart, also called a hypochart, we want to define the inputs. In this case, it's hours and pay rate, and the outputs, gross pay, taxes, and net pay. Once we know the input and output, we then need to decide how to get from the input all the way to the output. We're going to read the hours and the pay rate from the keyboard, determine the number of regular hours, determine the number of overtime hours, compute regular pay, compute overtime pay, and then compute gross pay. Compute taxes, and finally the net pay. That's what's left over after everything has been taken out. Finally, display the gross pay, taxes, and net pay. I am going to use flowcharts to continuously break down the program into smaller, manageable parts. Flowcharts are used to represent different steps of a program. The most commonly used symbols are those in the left column. Circle or rounded rectangle is used to indicate the beginning or end of a process. The parallelogram is used for input or output. The rectangle represents some type of process, and the diamond is used to represent a decision. Other symbols can be used to represent subroutines, functions, disks, databases, etc. The concept of structured programming states that all programs can be created with only three constructs: sequence, selection, and repetition, or a combination of any of them. Sequence is the easiest to understand. Program steps are executed sequentially, one after another. Many times, the order in which steps are executed is very important. Other times, it does not really matter. For example, if I were baking a cake, it may not matter very much whether I put the egg in the bowl and then the flour, or I reverse the two before mixing them with water. However, it would make a lot of difference if I put the cake batter in a 9 by 13 baking dish and placed it in an oven for 1 hour and 30 minutes, took it out, and then turned the oven on to 350 degrees. Yuck! This simplified flowchart shows the sequence of steps that are required for the program. There are no loops, so the repetition structure is not needed. In another slide, I'm going to expand the Compute Paycheck box to show a lot more detail. Here are two examples showing hours worked with an example of $20 per hour. The first example shows 37 hours, which is less than 40. Therefore, there's no overtime. All 37 hours should be paid at $20 per hour. The second example shows 45 hours. Therefore, the first 40 hours should be paid at the standard rate of $20 per hour, but the overtime of 5 hours should be paid at time and a half. That makes the overtime hours paid at $30 an hour. The easiest way for the program to compute the pay is to separate the hours worked into regular hours and overtime hours, then separately compute the pay for each. In this slide, I've expanded the flowchart to show more detail in computing the paycheck. The center column uses a diamond to represent a decision. The program needs to look at all the hours worked to see if they are less than or equal to 40. In this case, regular hours are set to the number of hours worked, and the overtime hours are set to 0. However, if the test condition is not true, that the hours are less than or equal to 40, that means that there is some overtime. Therefore, we set regular hours to 40 and we set the overtime hours to anything over 40. We can then proceed to compute gross pay, taxes, and net pay, and then display them. Program organization. Most of the programs you write will be organized like this. Use comments to place a title block at the top of each file. The title block identifies what this part of the program does, as well as the date, version, and programmer's name. It can be very frustrating later on when there are many files that make up one program, and you look at a file that contains code and have no idea what the code does. You then need to reanalyze or reverse engineer the code instead of just looking at a short description in the title block. Many companies want the programmers to place their name in the file in case anybody has questions about the file. The date and version number also help identify the latest version of the program. The first part of the real code contains the #include statements and any global variables and constants. Next is the main body of the program with its 4 subsections: list of variables, input, process, and output. Next, convert the algorithm into code. The C and C++ programs are very similar. All the logic for determining the regular and overtime hours, computing the gross pay, taxes, and net pay are exactly the same for both languages. The big difference at this point is just the input and output statements. I've placed square boxes where there's difference between the C and C++ code. The first one is for the include files. There's a slight difference between C and C++ include files. Include files help the compiler build the program. The second one is for inputting data, the hours worked and the pay rate. The last box is for output. Using Microsoft Visual Studio, I'm going to cover how to build your program using either Microsoft Visual Studio or Apple's Xcode. Here are the steps when using Visual Studio. Start Visual Studio, open a new project, name it Paycheck version 1.0, enter the program, test the program with multiple inputs. Although it may seem difficult to get the first program to work using Microsoft Visual Studio, it becomes much easier after you have done it a few times. Since this is your first C or C+ program, the steps are very detailed. Make sure that you read each of the directions carefully and don't move to the next step until you have completed the current step. 1. Start Visual Studio and select New Project. 2. Select Visual C++. Then select Win32 Console application. If you accidentally selected the XAML project, XAML, you will need to start over. Set the project name and location where you want it stored on disk. I recommend that you create a separate folder for each project. You may need to click the Browse button or to select or create a new folder. Click OK. When you see Welcome to the Win32 Application Wizard screen, click the Next button instead of the Finish button. Click the checkbox to turn off the pre-compiled header selection. Microsoft has an option to pre-compile header files. This feature can help speed up the compile process when there are several hundred source files that make up a very large project. With the size of the small projects in our class, you would never notice any speed difference if this feature is either turned on or off. The precompiled header feature must be turned off when building a C language project. The precompiled header feature should be turned off for C++ projects to make the C++ programs in Visual Studio compatible with C++ programs on other systems. Click the Finish button. Delete the Microsoft code that is provided and enter the code for your project. For a C project, instead of C++, rename the file with the .c file extension. Unless you're debugging the programs, click Debug on the top menu and then Start Without Debugging or Control plus F5. Otherwise, the console output screen will disappear before you can even see what happened. If there are any errors, fix them and then try again. Run the program 3 times with different data and fill out the lab report. Use Microsoft's snipping tool with the mouse to select the output window. Then click to save the image to the clipboard. Use Ctrl plus V to paste the clipboard into the lab project. Here's a brief description on how to use Xcode on Apple's Mac OS X. Start Xcode. Select the command line tool. Enter the project name. In this case, it's Paycheck. You also need to select an organization name and organization identifier. Select either C or C++. You may need to select the menu option Navigate and then select Reveal in Project Navigator. Click main.cpp or main.c located in the left panel to go to the code window. Delete the code that Apple provided and replace it with the C or C++ code for the program. The code for the program is located on the Canvas class website. From the main Xcode menu, click Product, then Run, or you can use Command R. If there are any typing errors, fix them and try again. When the program runs, you will be the user. The user input and output is in the output window. It is important that you click in this window before inputting data, such as the hours worked and pay rate. If the code window is active instead of the All Output window, you will be modifying your code instead of inputting data into the program. You may need to resize part of your screen to see all of the output lines that the program is displayed. Capture only the part of the screen that shows the output window. Click Command plus Shift and then the number 4. Use the mouse or keypad to select and copy the output window to the clipboard. You can then paste just the output window into your lab report. You can choose to do the project either in the C language or C++, but you will only get credit for one submission of the project. The code is provided as an image file. You need to type in the program to complete the lab project. Be very careful when typing your program. Except for comments, C and C++ are case sensitive, which means that the uppercase letters, capital A through capital Z, are treated completely different from the lowercase letters, small a to small z. Do not put spaces in the middle of variable names. Example, overtime pay has no spaces. Watch the placement of the semicolon character. It does not appear at the end of every line. Use \n for C programs and ENDL for C++ programs. The \n uses a backslash, not a forward slash. The ENDL stands for end of line, and the last character is a small l, not the number 1. Pay close attention to the parentheses, the curly braces, and the angle brackets. This slide shows both the C and C++ programs. If the text is too small, don't worry about reading it yet. I'll zoom in for different parts during the discussion. The title block at the top of the program file uses the C-style language comments, starting with a /* and ending with a */. The comment block identifies what is in the file as well as the inputs and outputs. Some companies want the programmer's name in the title block, others don't. I want your name in the title block, and I will look for it when I grade your projects. Although not shown here, another couple of things that are usually placed in the title block are the version number and the date. This can help determine the latest version of the code when there are multiple files that are not the same. The #include statements bring in additional code that helps the compiler build your program. Look carefully. There's no semicolon at the end of the #include statement. Some other programming languages use the word import instead of #include. The C language needs #include stdio.h to correctly compile the scanf and printf statements used for input and output. It is proper to pronounce stdio.h either by its letters stdio.h or call it standardio.h, but not studio.h. There's no U in stdio.h, and this has nothing to do with a rock and roll recording studio. Look at the C-style comments, /* and ending with a */. They are used for creating a block of comments. This style of comments can be used in both C and C++ programs. The #define statement is a preprocessor directive that can be used in C to define constants. It causes a text replacement while the program is being compiled. This would be similar to the find and replace feature in a word processor. Anywhere that the characters _rate appear in the program, they would be replaced with the characters 1.5. Because the #define is a text replacement, it is important that neither the equal sign nor the semicolon character are used in the #define statement. Otherwise, those extra characters would also be added into the program before it is compiled. Although not required, it is common practice to use all uppercase characters and the underscore when defining constants. This helps make them easier to recognize when looking at the code later. Constants are used later in the program so that the values will have a name instead of just a number. For example, when tax_rate is used in the expression taxes equal gross pay times tax_rate, it's much better than taxes equal gross pay times 0.17, because someone looking at the program might wonder where that 0.17 came from and why it is there. If the 0.17 were used, it would be referred to as a magic number. Who knows how it got there? Another reason to define tax rate at the top of the program is that it may end up being used more than once in a larger program. Changing it where it is defined makes sure that it gets changed everywhere. Now, look at the C++ version of the program. You'll probably see #include IOStream statement in many of the C++ programs. The IOStream library is provided by the compiler manufacturers to give access to the console device's keyboard and display. We'll also use #include IOmanip in this program because we want to display gross pay, taxes, and net pay with 2 digits past the decimal. Look at the C++ style comments, // The C++ style comments start with a // and end at the end of the line. Although this style of comment was introduced with C++, most modern C compilers accept both types of comments. Compare the difference in how C and C++ define a constant. Instead of a text replacement, we are actually creating data with its associated data type and using the equal sign to assign it a value. The semicolon is used at the end of the assignment statement. By using const double overtime underscore rate equal 1.5 semicolon, we now have the value 1.5 stored in memory. Console applications start with int main. You can either use int main open parentheses int argc comma character star argv open close square bracket close parentheses or int main open close parentheses. The argc and argv parameters are only needed when a different program is passing data directly into the program you are writing. The curly braces are used to identify the start and end of a block of code or data. Many other programming languages use the words begin and end instead of curly braces. I suspect that the original developers of the C languages did not like to do a lot of typing and also thought, wow, I wonder what I can use this character for. This program is using the double data type for variables. The data type int is used for integers, whole numbers. The float and double data types are used for real numbers, which can hold digits past the decimal point. Back in the old days, when C was first created, many of the computers only had a small amount of RAM and did not have a built-in math coprocessor to process real numbers. It was necessary to use as little memory as possible to reduce the amount of time required to process floating point numbers. Now that we have more memory, math coprocessors, and faster computers, the double data type is most often used to hold floating point numbers. Double means double precision floating point number. Constants and variables must be declared before they can be used. I placed the constants and variables at the top of the program and even declared several variables on the same line with a comma between each variable name. Some companies require that each variable be declared on its own line. When writing a console application, it is necessary to output a prompt to the screen to request data from the program's user. If you don't have a prompt message, all the user will see is a flashing cursor and probably think the program has crashed. C programs use the printf statement to output to the console screen and scanf or scanf underscore s to read from the console keyboard. C++ programs use cout to output the console screen and cin to read from the console keyboard. If you want to sound like a cool programmer who is in the know, watch how you pronounce these names. Scanf, printf, cin, cout. If you pronounce cin as sin, people might think you're trying to lead a church congregation instead of writing a C++ program. BASIC used the print statement and C used the printf statement because we used a printing teletype as the console because the video displays weren't invented yet. When writing a prompt message, I like to end the prompt with a colon and a space to let the users know that they need to type something in. The space after the colon is used to make the screen look nice so that the user's typing won't be right next to the prompt. A much more detailed description of these routines will be provided in a later video. This video only covers printf, scanf, cout, and cin as they are used in the Paycheck program. The scanf statement in a C program is a little more complicated to understand. The first thing to notice is that I'm using scanf underscore s instead of just plain scanf. The plain scanf has been deprecated, which means that it is old and out of date. The original scanf could cause problems when reading a string of text characters if someone typed more characters than scanf was expecting. This could cause a buffer overflow, resulting in the program to crash or provide a way for evil people to insert a virus. Microsoft has updated their version of scanf and called it scanf underscore s. The underscore s means secure. Apple has updated their version of scanf but still calls it scanf. The first parameter in a call to scanf is the format string. It is surrounded by double quotes. The format string tells scanf what type of data is expected to be typed at the console. The Paycheck program is using quote %LF quote because it is expecting data that may have digits past the decimal, and the data is going to be stored in a variable whose data type is double, also known as long float. When you're typing in the program, make sure that you type %LF with a small l and not the number 1. Each part of the program likes to protect its own area in memory and its own data. It is like there is a magical barrier between the scanf routine and your program that, under normal circumstances, cannot be crossed. Since scanf needs to place the data it read from the keyboard into your part of the program, it is necessary for your program to provide the address of your variable to scanf. For example, if the 4 characters 37.5 are entered at the keyboard and the scanf control string is %LF, scanf internally converts those 4 characters into a floating point number. Because your program is providing the memory address of its own variable named hours, scanf knows how to store the data in your part of the program. With C and C++, cout uses the insertion operator less than, and cn uses the extraction operator greater. They're referred to by these names with the idea that cout is inserting data into the output stream and cn is extracting data from the input stream. The easiest way to remember them is to think of them as arrows and look at the direction they are pointing. Data is going out to the console for cout. Data is going from the keyboard when using cn and being placed into a variable. The if-else statements are used to identify the number of regular hours worked and the number of overtime hours. The if statement has a logical expression enclosed within the parentheses that is testing to see if the hours are less than or equal to 40. The logical expression must evaluate to either a true or a false. When the expression evaluates true, that means there is no overtime and the block of code that is attached to the if statement is executed. When the expression evaluates false, the block of code attached to the if statement is skipped over and the code attached to the else statement is executed. The curly braces identify the begin and end of each block of code. If there is no overtime, just set the regular hours to the number of hours worked and the overtime to 0. If there is overtime, the first 40 hours get paid at the regular rate, but anything over 40 gets paid at time and a half. Set the regular hours to 40 and the overtime hours to anything over 40. Since this program can process a paycheck that does not have overtime, 40 hours or less, and also a paycheck that has overtime, more than 40 hours, it is important to test both conditions. It is also important to test the program at 40 hours. The computations for regular pay and overtime pay are fairly straightforward. Reg pay equals reg hours times pay rate. Overtime pay equals overtime hours times pay rate times overtime rate. The overtime rate is from the constant 1.5 at the top of the program. The gross pay, that's the pay before deductions, is the sum of reg pay and overtime pay. Taxes are based on the tax rate defined at the top of the program. Net pay is anything that is left over from the gross pay after the taxes have been deducted. When using C, the first part of the format string in printf is just text that will be displayed. Your pay is, and $, followed by the format specifier %0.2LF, and then \n, which moves the cursor down to the next line. The %0.2LF tells printf to replace the 0.2LF with the data that is in the next printf parameter. The LF identifies that the data is expected to be of type double, and the 0.2 says a minimum of 0 characters on the screen, including the decimal point, and 2 characters past the decimal. If pay were computed at 803.0, then the output on the screen would show your pay is $803.00, and the cursor would move down one line. Remember how printf displays 2 digits past the decimal. You will need this in future lab assignments. If you thought that printf was a little complicated in displaying 2 digits past the decimal, look at how C++ does it. We need the #include IOManip statement at the top of the file. We also need cout >, set iOS flags, iOS : fixed, the vertical bar, which is a bitwise OR, iOS : show point, close parentheses, semicolon. Now all we have to do is set precision, open parentheses, 2, close parentheses, before displaying a double data type. The cout statement uses the insertion operator to string several pieces of the message together when forming the console output. Cout your gross pay is $, quote, set precision, open parentheses, 2, close parentheses, gross pay, ENDL, semicolon, has 4 parts. The first part is just a string of text characters. Next, sets the precision to 2 for the following variable, and finally, ENDL to cause the cursor to move to the next line. Make sure that you type the last letter of ENDL as a lowercase l, because ENDL means end of line. Using ENDL twice moves the cursor down 2 lines. Depending on which development system you're using, you may need to insert the line system, open parentheses, quote, pause, quote, close parentheses, semicolon, right before the return 0, semicolon statement to prevent the output window from closing before you have the opportunity to look at it. This will not be necessary if you're using Xcode or NetBeans. It also won't be necessary if you use the Control plus F5 to start a Microsoft Visual Studio C++ program without debugging. This may seem like a big task for your first program, but a lot of code is missing to make a robust program that is more user-friendly and able to detect and handle bad inputs. Here are some of the things that are missing that we will need to learn how to process in later projects. Check for negative hours, pay rate, or taxes. Check for hours greater than 168. Check for excessive pay rate or tax rate. Check for illegal inputs. Project documentation and lab report. A multi-page text document for the lab report is provided. Most of the lab report for this first project is already filled in. You need to complete the rest of the lab report. You need to complete the test values and results table. I've already provided some sample test values. If you use any values other than 39, 40, and 41 hours, or a pay rate other than $20 an hour, you need to update this table. Use a calculator to compute the expected results, and then put in what was computed by your program in the actual results column. Don't just copy the program output into the expected results column. Otherwise, how are you going to know the program is actually producing the correct results? When you submit your lab assignment, I may be comparing the data in this table to the 3 screenshots that are also part of the lab report. In the discussion section of the lab report, you need to write what you did to develop the program, any problems you had, and how you overcame those problems. I don't expect a lot of writing, but I want you to describe what you did for the project. I realize that not everyone taking this class may have perfect English. Try your best. I may mark up your report for English composition problems to help you in your writing, but I will not take off any points for your English. This is a programming class, not English 1A. The lab has instructions on how to copy just a small portion of the screen. If you place a screenshot of the entire screen, I may not be able to read the output of your program. If this happens, I may ask that you resubmit your report. Congratulations on completing your first C or C++ assignment. I hope that you are not only able to complete just the lab report and submit it, but also that you gained an understanding of how this program works.